Good morning, everybody. Today we have to discuss about the electromotive force chapter for the second semester students. So, in this chapter, in the previous class we have to discuss about the galvanic cell and its functioning and role of salt bridge. So we have to discuss about the galvanic cell, and in first semester chapters we have to discuss about the electrolytic cell. So what we have to observe the in between two cells, that is the differences between electrolytic cell and galvanic cell. Look here how we have to constructed the electrolytic cell, how we have to constructed the galvanic cell. Suppose electrolytic cell, we have to take in only one container, in that pour the one electrolytic solution and dip it two rods within the one solution. We dip two rods and the two rods are connected with the one of the external agency which is called as battery. So these two rods are same rods, and when these two rods are connected with a wire, two terminals of the battery, suppose which rod we have to connected with the positive terminal, which rod we have to connected with the negative terminal. Which is connected with the positive terminal is called as anode, which is connected with the negative terminal is called as cathode. So here also anode, cathode is there. We have to decide to cathode, anode, and one of the electrolytic solution is there, one container is there, one electrolytic solution is there, same two rods are there. Two rods are connected with the two different terminals, means that there are two terminals of the battery. Then we have to decide the which is the cathode, which is the anode, and when we have to make as a construction in that cell, a anode cathode is formed. At cathode always be takes the reduction reaction, at anode always be takes the oxidation reaction due to the electrolytic solution. So same as usually in the previous class we have to discuss about the galvanic cell and construction of the galvanic cell. Galvanic cell, in the galvanic cell we have to take the two separate containers and two separate two rods and two separate two electrolytic solutions. Then these two rods connected each other with a circuit through a voltmeter, and we have to take the one of the U-shaped tube and inverted, and two solutions are linked. These two solutions are two of cells are linked. This is the construction of galvanic cell. So look here. So what is the electrolytic cell? In which cell we have to chemical reaction takes place by the process of electricity is called the electrolytic cell. So galvanic cell, in which electrolytic cell, which cell is electricity is generated due to the chemical reactions is called the galvanic cell. So here electrolytic cell requires a source of external agents energy. We are connecting the battery, but in galvanic cell it is a source of energy. There is no any external agencies. So in this cell, anode designed at positive, cathode will be represented with the negative in electrolytic cell. In galvanic cell, anode you have to represent it with the negative sign, and cathode positive side. And you have to observe and remember the how is the construction. If you have the construction in your mind, automatically you have to differentiate these two electrolytics, these two cells. So electric current flows from in the electrolytic cell. Electric current flows from anode to cathode. This is the quite opposite. Why in electrolytic cell current flows from anode to cathode? Anode to cathode. So here cathode is the was giving the electrons in the electrolytic cell. That's why current will be flows from anode to cathode. Electrons will be flows from the cathode to anode. So look here. Whenever we have to observe the galvanic cell construction, electric current flows from cathode to anode. Why? Because the flow of the electrons takes place from the anode to cathode. In galvanic cell, anode will be losing the electrons that will be moved towards the cathode. So anode giving the electrons, that electrons only moving towards the cathode. In electrolytic cell, that cathode will be giving the electrons, that electrons moves towards the anode. That's why current will be anode to cathode. Here current will be cathode to anode. In electrolytic cell, we does not take the any salt bridge. We don't require the any salt bridge. But without salt bridge in the galvanic cell, we not continuous the power generating will be takes place. So, dear students, once again, and you have to observe the construction and mind. You keep the construction of the electrolytic cell and galvanic cell in your mind, then automatically you have to differentiate in between them what you are observing the in the construction only. Definition will be we have to by passing of current here energy will be converting electrical energy converted into the chemical energy in the electrolytic cell. Here, chemical energy is converting into the electrical energy in the galvanic cell. So simply you have to first point what we are I showing in the points. Not only that one, you have to arrange your in your own way in which cell. Otherwise, which cell converting the chemical energy into the electrical energy is called as galvanic cell. Which cell converting the electrical energy into the chemical energy is called as electrolytic cell simply. So in electrolytic cell, we are connecting the battery, means nothing but we have to external agency. But in galvanic cell is a energy source. There is no need of any external agencies. So in this cell, anode positive, cathode negative in electrolytic cell. In galvanic cell, anode negative and cathode is positive. And electrolytic cell, electric current flows from anode to cathode. So when you have to observe the construction, you first of all observed electrons from moving from anode to cathode or cathode to anode. You have to observe the Electrons in electrolytic cell, electrons means nothing but phase neutral is there. Otherwise, two terminals, battery, for the battery, two terminals are there, positive terminal and negative terminal. Negative terminal should be giving the electrons, that should be electrons are moving towards the positive terminal of their battery. So here negative terminal means nothing but cathode, positive terminal is nothing but anode. So here cathode, electrons moving from cathode to anode, current will be quite opposite to the moving of electrons. So you can simply, you have to remember only one way, electrons from cathode to anode in the electrolytical cell. So current will be flows from anode to cathode. If we remember the only one point, then you have to write the 4 points, 2 points in every cell. Electrons from cathode to anode in electrolytical cell. Only one point. Remember, electrons are flowing from cathode to anode. Quite opposite in galvanic cell. Electrons from anode to cathode. Current. Here cathode to anode. Current in electrolytical cell. Anode to cathode. Same as usual. Cathode to anode. Current is cathode to anode. Here we are using the salt bridge in the galvanic cell. Here in electrolytical cell, we no need, not required that salt bridge. So this is the differences between electrolytic cell and galvanic cell, and very important question it will be asking in every board examination paper. You should be remember and be carefully. So standard electrode potential. So first of all, what is the electrode potential? The tendency of electrode to lose or gain electrons when it is in contact with its own ions in solution is called electrode potential. So we have to standardize that electrode potential by maintaining the standard values of electrolytic solution and temperature, solution concentration and temperature, and electrode and pressure. So first of all, what is the electrode potential? The tendency, what do you mean tendency is nothing but capacity, capacity of that capacity of electrode to losing of electrons or to losing of to gaining of electrons by its own ions in the solution is called as electrode potential. Electrode potential. An electrode or op cell contains a metal, okay, which is called as the electrode and electronic conductor, and aqueous solution of metal ions, electrolytic solution or electrolytic conductor. So at the surface of the separation of the two phases, potential difference exists, which is known as the electrode potential. Electrode potential, oxidation and reduction potentials. So here oxidation takes place at anode and reduction takes place at cathode. So what is the meaning of the oxidation? The losing of electrons means nothing but losing capacity or losing tendency. The tendency of an electrode to lose the electrons is called the oxidation potential. Same as usually the tendency of the electrode to gain the electrons is called the reduction potential. Generally, we have to electrode reaction is suppose metal gives to metal plus n number of electrons, then you have to represent it as like that. So oxidation and reduction potentials. The forward reaction is oxidation and reverse reaction is reduction. The forward reaction is oxidation and potential concerned to this reaction is oxidation potential. Oxidation potential. The backward reaction is reduction and potential concerned to this reaction is reduction potential. The oxidation potential is equal to the reduction potential in magnitude but opposite in sign for, for an electrode. So when we have to here observe M is a metal, it will be when gives to M plus N electrons will be loses plus 2 electrons. Whatever it may be, that forward reaction we have to observe losing of electrons takes place oxidation. That capacity is called as that is oxidation potential. The when we have to another one symbol is we have to observe here reverse are nothing but backward words backwards means nothing but m plus n plus n number of electrons. When we are adding the n number of electrons means nothing but adding or gaining of electrons m plus n, then automatically it will be formation of m means nothing but metal. So that is called as reduction. Gaining of electron is called as reduction. The capacity that gaining of electron capacity of that metal is called as reduction potential. Okay, reduction potential. This is the potential and some more examples are there. Listen here. Whatever we have to observe the oxidation potential and reduction potentials. As usually same capacities but quite opposite. Suppose oxidation potential is equal to minus reduction potentials. The oxidation potential of zinc electrode, for example, zinc electrode you have to represent the zinc slash zinc plus 2 means that is whatever we have to observe here, that is the electrode symbol. That electrode we have to represent it as a zinc slash zinc plus 2 is equal to plus 0.76 volts. Zinc gives to zinc plus 2 electrons in the reaction form. This is the electrode, and in the reaction form, zinc gives to zinc plus 2 electrons. This reaction is oxidation reaction. That's why this potential is this capacity is 0.76 is nothing but what is the oxidation potential? Oxidation potential. If that reverse reaction, zinc plus 2 gives to zinc 2, this is the reverse reaction. Zinc plus 2 electrons gives to zinc 2. This electrode we have to represent it as a zinc plus 2 slash zinc. electrode, and its value is quite opposite in the same magnitude but quite opposite, minus 0.76 volts. So that is the electrode potentials. And when we have to standardize that electrolytic solution and electrode and temperature and pressure, then that electrode potential is called as standard electrode potential. So the potential of an electrode depends on the concentration of electrolyte, temperature, valency, nature of the electrode, and pressure. Pressure. Then we have to make standard values. Then that electrode potentials are called as standard electrode potential, which is we have to represent it with the E naught. Listen here. Standard electrode potential depends on the potential of an electrode depends on the concentration of electrolytic solution which we have to take in solutions in the two options. Temperature, which temperature we have to maintaining always be room temperature. Pressure always be 1 atmospheric pressure we have to maintain the at room temperature. Concentration always be 1 molar of concentration. When we have to maintain these standards, then that potential capacity is nothing but losing or gaining capacity is called as very simply standard electrode potential. That's why that is represented with this E naught. You have to just now given the perfect definition. Thus, for comparison, the potential of the electrode is standardized by keeping the concentration of electrolyte at 1 mole and pressure of the gas at 1 atmospheric and temperature is 25 degrees Celsius. The potential of an electrode at 25 degrees Celsius with 1 molar concentration of electrolyte is called the standard electrode potential. Okay. Standard electrode potential as per IUPAC, what do you mean? International Union of Pure and Applied Chemistry. That is the nomenclature. They will be giving the name. So, convenience. The reaction occurring at the electrode is represented as the reduction reaction. Hence, the standard electrode potentials are referred as standard reduction potential also, but every often the word reduction is omitted. The electrode reaction should be written as electrode reactions: zinc electrode, copper electrode, hydrogen electrode, chloride electrode. So when we have to observe here, zinc electrode means zinc rod, copper electrode is copper rod. These are the metals. This is the electrode and electrode reaction. Electrode and electrode reaction. Here hydrogen and fluorine is the gases. This is the non-metal electrodes. Non-metal electrodes. Hydrogen electrode. In the hydrogen electrode means nothing but we have to maintain the a universal electrode is there, that is the platinum. In non-metal electrodes we have to use the platinum, always be act as a electrode platinum. Non-metal electrodes. An electrode or op cell is also constructed by using a non-metal in contact with a solution containing its own ions act as the electrode. As non-metal are non-conductors, a metal such as platinum is used for the electrical contacts. For example, platinum. H2 gas we maintained at 1 atmospheric pressure and 1 molar concentration. Hydrogen electrode, oxygen electrode, chlorine electrode. For the oxygen electrode, oxygen oblique OH minus. Cl2 means Cl minus. H2 means H plus ions are there. That's why this is the hydrogen electrode, oxygen electrode, and chlorine electrode. These are the electrodes and electrode reactions, and further classes we have to discuss about the cell reactions and representation of cells. So once again listen here. In this session the very important question is nothing but write any four or some more, but you have to remember at least four differences between the electrolytic cell and galvanic cell. Simply you have to take the one point is the definition, and uh, electrode which is the negative, which is the positive, and current flows from there and there, and electrons flows from there and there, and salt beds require or not required. These are the very important and very simple. And standard electrode, how can we have to call as the standard electrode? When we have the standardize the electrode potential, what is the electrode potential? Electrode potential is the capacity or tendency of an electrode to losing or gaining capacity is called as the its potential. If the losing capacity is called as oxidation potential, if the gaining capacity is called as the reduction potential. And it's represented with the one of the reaction m gives to m plus n, n number of electrons. Then so forward reaction is called as the oxidation potential, backward reaction is called as the takes place reduction potential. So oxidation potential we have to always be, we have to take in the positive nature, and reduction potential we have to take in negative nature. And by this, these two oxidation and reduction potentials are quite opposite but same in magnitude. And for the examples, you can take oxidation potential is equal to minus reduction potentials, and the oxidation potential of zinc electrode if plus 0.76 volts, then what is the reduction potential of zinc electrode means nothing but minus 0.76 volts. So when we have to standardize, then we have to maintain the concentration of electrolyte and temperature of the room and pressure of the room, maintain the at 1 molar concentration, 1 atmospheric pressure, and at 25 degrees Celsius, then it will be called as standardized electrode potential. Then it is simply we have to say standard electrode potential, which is represented with the E naught. And some more electrodes we have to represent it in the form of zinc plus to zinc, copper plus to copper, platinum, and so metallic electrodes and non-metallic electrodes. Non-metal electrodes also hydrogen electrode, oxygen electrode, chlorine electrode. And in further classes we have to learn about the galvanic cell and cell representation, cell reaction, and electromotive force, and how can you we calculate the electromotive force.